NASA detected a huge unknown object arriving from another solar system. The object is the interstellar trespasser 21 Borisov, the cleanest comet ever seen. What's even more unlikely is that this rogue comet has never previously come into contact with a star before coming to ours. Due to its unusual speed and trajectory, scientists have concluded that the comet originated in interstellar space, making it the first interstellar comet visitor to our solar system. Researchers have revealed two ways in which 21 Borisov stands apart from every other comet humans have come across. The comma of 21 Borisov, an envelope of gas and dust around its core, was studied by analyzing light scattered off dust grains using the Very Large Telescope at the European Southern Observatory. In particular, they looked at the light's polarization and how its waves moved through space and in what direction and how fast. Light waves may go in any direction, including straight up, straight down, left, right, or any angle in between. The more strongly light is polarized, the more uniformly its waves ripple. A comet's surface may be changed by a star's radiation and winds as it travels near the star, like our skin when we go to the beach. This in turn can lessen the polarization of the comet's comma light. The researchers found that the light coming from 21 Borisov's comma was highly polarized, which suggested that the comet's surface was less contaminated than the surfaces of other comets, since it was seldom exposed to the light and winds from stars. It indicates that if a comet gets close enough to another star, the sun will begin to slowly process the material on the comet's surface. Nevertheless, the polarization of light throughout 21 Borisov remained consistent, which means that 21 Borisov may be the first comet that was ever discovered that was completely uncontaminated. It's possible that it had never come close to any star before it entered our solar system, which would have left it as an unmodified relic of the cloud of gas and dust that it came from. Another surprise revelation that came from the comet's composition is comparable to that of the early solar system, implying that the environment in which 21 Borisov formed was not too different. As a result, studying this comet can provide us with a wealth of information about the formation of the solar system through its birth. Studies of comets that have never come close to the sun are especially productive, because the material on those comets is likely to be the same as that which was present during the formation of our solar system. As a result, these types of comets can lead to the discovery of groundbreaking new information about the birth of our solar system. Data collected by the Atacama Large Millimeter and Submillimeter Array in Chile and the Very Large Telescope at the European Southern Observatory were studied by experts to learn more about the origin of the comet and the solar system it originated from. For a very long time, scientists have had an interest in learning about other planetary systems that originate similarly to our own, but we were unable to examine these systems down to the level of their individual comets. That's because comets that originate in other solar systems cannot be observed by our telescopes because they are simply located too far away and are too tiny. The fact that a comet that originated in a system many, many light years distant made such a close encounter with Earth is extraordinarily fortunate for mankind in this case. The researchers discovered that the dust in 21 Borisov's comma was made up of tiny stones, each of which measured at least 2 millimeters across. On the other hand, the dust that comes from other comets in our solar system is often made up of uneven, fluffy clumps of material that range in size from around 2 micrometers to about 1 meter broad. Previous studies have shown that the comets in the solar system evolved in a large region beyond the orbit of newborn Neptune. When the larger planets such as Jupiter and Saturn moved to their current places, the powerful gravity of these planets flung these comets out to their present location in the outer solar system. So the first assumption that this comet will be in our solar system is dismissed due to the fact that the pebbles of Comet 21 Borisov are so densely packed together that it lends credence to the theory that they were produced by cosmic collisions that occurred in close proximity to the comet's host star and mashed the comet's material into compact pieces. And then the comet was eventually flung out into interstellar space when the huge planets that orbited its sun ejected it into space. And after traveling for many light years, it's finally come to our solar system, its first encounter in its life. In Chile, the extremely large telescope being developed by the European Southern Observatory should cast even more light on these visitors from interstellar space. So, there's a lot of hope for the future when it comes to finding and figuring out what objects from other solar systems are. That's all for today's video. Thanks for watching. See you in the next video. Until then, bye.